Alright guys, go ahead and grab out paper. We're just going to do some problems out of the packet since I messed up the packet. So this is 3.7, more on it. So we got 4 problems in this video. Just write them down on your own sheet of paper. So we learned implicit versus explicit differentiation. So you could see this equation of the circle and solve it and say that y squared is 4 minus x squared, and then we could square root both sides. Remember, when we square root, that's what we get. So we get that y equals the square root of 4 minus x squared, and y equals negative square root of 4 minus x squared. This is explicit when you get it in y equals form. Because now when we derive, we can say, okay, let's find dy dx. Remember, this is like the 1/2 power. We have 1/2, or derive the outside, keep the inside, subtract 1, and multiply by the derivative of the inside, which is negative 2x. Now most days I say you don't have to simplify, but I think it's actually really helpful to simplify here, because we are going to see that whether you derive explicitly or implicitly, you get the same derivative. So when we simplify this, we would get negative x over the square root of 4 minus x squared. But remember, from this first part here, y is equal to the square root of 4 minus x squared. So what we actually found here is that the derivative equals negative x over y. Usually we keep things in terms of x when it's explicit, but I want to show you that implicit would get negative x over y as well. For the sake of the video, if we derived the negative root, we would also get that. And remember, all the roots do, one gets the top of the circle, so that's the positive one, and then one gets the bottom of this circle, which is the negative. Okay, so if we derive both of them, we would get negative x over y. Feel free to try with the negative root, you would still get negative x over y. Well, implicit differentiation, that says you don't have to get it in y equals form. You can just derive it as is. So if we have our function, you can just say, let me derive x like we do. We do the same with y, but remember, anytime there's a y, let's sneak parentheses around it. So we drop the power and subtract 1, so that's now y, 2y to the first power. But then we have to multiply by the derivative of the inside, which is dy dx. And this part is missed a lot. The derivative of our constant is 0. So we even have to derive that 4. Now if we're trying to say what dy dx is equal to, we just have to move around our equation here. So we're going to subtract the 2x onto the other side, and then here we're going to divide by the 2y. So dy dx, when we simplify those two, notice it's negative x over y. So whether you do it explicitly or implicitly, it's up to you. Once in a while, the problems have options where you can do it either way. However, we'll see in a few problems from now, you will have to do it implicitly. Alright, go ahead, and now that we know our slope, let's find the tangent and normal lines. The difference when it's implicit differentiation, you get an x and a y, because to find the derivative, you need both points in there. So, you have your point you're finding it at, find your normal and tangent line, and play the video to check your answer. Alright, check out those tangent lines. Is that what you got? If so, nice job. If not, trace back how we got these slopes from our formula here. Alright, next up we have a trickier one, but not too tricky. We want to find the derivative at 0, 0 of the function here. So notice we don't need the tangent line this time, we just want to know what the slope is at 0, 0. Well, tangent of x plus y equals x is our function. and we want to derive both sides. And so we have a chain rule here. We derive the outside, which is tangent. Tangent goes to secant squared. We keep the inside, but then we multiply by the derivative of the inside. So x's derivative is 1, plus y's derivative is dy dx. And again, it's really common we forget to derive the other side. Don't call the other side x, call it 1, because everything gets derived. Now this is where this one is just the slightest bit tricky, because we're trying to get this dy dx by itself. I guess there's a couple ways we could do this. We could just divide everything. Actually, that might be easier than the way I had planned. Derive everything by that. I'm sorry, divide, not derive. And then we're left with 1 plus dy dx equal to, you know what? I'm actually going to say 1 over secant squared. Remember, secant is the inverse of cosine. So if we're in the inverse of the inverse, this is actually the same as cosine squared of x plus y. And if we want dy dx, we just have to subtract 1 over here. We needed this to be derived implicitly because there was no way to get this into y equals form. We can't separate that y from the tangent. And so because we couldn't do that, that's where implicit differentiation is really cool, that we can still derive in this form. Alright, the last step was find the derivative at 0, 0. So let's go ahead and plug it in. Cosine squared of 0 plus 0 minus 1. Well, if we think of our unit circle, cosine at 0 is 1, so this turns into 1 squared minus 1, which equals 0. So remember, that is a flat slope, a horizontal tangent line. Okay, implicit differentiation. Let's see it. Our third problem today. This one just says find dy dx. We don't have to do the tangent line. We don't have to find it at a certain point. But this is what this equation looks like, this little almost ribbon looking thing. So we are going to derive everything. So when we derive here, we just get 4. When we do this, notice I'm only putting the y in parentheses because it's y squared, not 6y squared. So when we drop our power, that becomes 12y to the first power, but the chain rule says derive by the inside, which is dy dx. Next we get that we have to derive what it equals, and so I'm going to choose to keep the 2x together and the y. So we're going to do first times the derivative of the second plus second, actually I'm going to leave some room there, plus second times the derivative of the first. Better to call it 2y than y2. So what this form is saying, we want it in dy dx equals. And so this is what we did in class right at the end. Whatever term is dy dx, get it onto one side. Whatever term isn't, get it onto the other side. So I'm going to keep this 12y dy dx here. And I'm going to keep this 2y here. I'm going to end up moving this 4 here over. And this term needs to come over. So we do that by subtracting it off the side. And so we're getting closer to dy dx equals. Once we get all the dy dx's on one side, we can go ahead and factor what they have in common out. So 12y minus 2x. And it equals this 2y minus 4. Well, the last thing to get dy dx by itself is to divide off what's in the parentheses. So 2y minus 4 gets divided by 12y minus 2x. So that is the slope at any point. So that's the thing with implicit. You do need an ordered pair to find the slope because x and y will be in your final answer. But for this little ribbon up here, any point on there follows this for the slope. Okay, we have one more I want to do. Nope, we already did that one. Oh, here it is. I want you to pause the video and try this one on your own. See what you remember from the other ones, go back to your notes, and then play the video when you're ready to see the answer. Alright, so go ahead and check your steps. I tried to put the description on the left of what I did in this step. And if you have questions, I will be back tomorrow to help. So please be ready to ask them. We have a work day in class. Whatever time you have left now, start your homework of 3-6 and 3-7, and then when I come back, be ready to ask your questions.